Just imagine for a second a city where traffic just flows. No gridlock. All of it managed by this powerful, flexible AI that adapts to everything in real time. It sounds incredible, right? But the journey from a computer lab to our actual city streets is, well, it's anything but smooth. So today, let's dive into the 7 biggest hurdles, everything from the code itself to the cold hard cash that we have to get over to make this a reality.
In this slide, this really gets to the heart of it. On one hand, you have the dream, this powerful, adaptive brain for our city. But the reality? The reality is that building it is incredibly complex, it's super demanding on our infrastructure, and believe it or not, it can be pretty fragile. This tension, right here, between the ideal and the real, that's what we're going to unpack.
All right, first up, let's pop the hood and look at the engine itself. Because before this AI can make a single decision about a single traffic light, it needs a massive foundation of code, serious computing power, and just tons of data to even get started. To give you an idea of the sheer processing power we're talking about, look at what has to happen every single second. The system is constantly running this intense 3-step calculation just to make one decision. It has to look at all the possible traffic scenarios, filter out all the noise from the sensor data, and then use its neural net to predict the absolute best move. Doing that over and over again nonstop, that creates a colossal computational workload. And all that heavy lifting means you can't just run this on a standard office computer. Nope. To make decisions fast enough to actually be useful in the real world, the system needs specialized and, expensive hardware, like GPUs. Without it, the whole thing is too slow. And a smart system that's always a few seconds behind could actually make traffic even worse than a simple old-school timer. Okay, so let's say you have the computing power. You've got the horsepower. But what good is a powerful engine if you don't give it any fuel? And that brings us to the next critical piece of the puzzle: data. You have to understand, without a constant fire hose of information, the AI is basically flying blind. It needs a huge network of sensors just to see what's happening on the streets. It really struggles in areas with spotty coverage, and it needs mountains of historical data just to learn the basic traffic patterns of a city. For a lot of places that just don't have that kind of sensor network built out, a system like this is, frankly, a non-starter from day one. Okay, so let's imagine we've got the hardware and we've got the data. We're good to go, right? Well, not so fast. Now we have to look at the brain of the operation itself, the AI. And like any brain, it has its own built-in blind spots and, let's say, learning challenges. This is one of the absolute biggest problems in AI research today. It's called the simulation to reality gap. See, in a computer simulation, the AI can safely try out all sorts of wild ideas to learn. The data is perfect, the patterns are clean, but out here, in the real world, you can't just test a random, potentially dangerous traffic light pattern at rush hour. Real-world data is messy, and we humans are famously unpredictable. Trying to bridge that gap between the clean lab and the messy street is a massive, massive challenge. And all of this leads to an even bigger, more fundamental question. Even if the AI seems to be working, if we can't understand how or why it's making its decisions, can we really, truly hand over control of our city's intersections to it? And this gets right to the core issue: trust. While some parts of the system are built on clear, understandable math, the decision-making brain, the part that learns from trial and error, which is called reinforcement learning, is often a total black box. A city's traffic engineers are responsible for public safety. It's their job. And they can't just sign off on a system when it can't explain why it decided to turn that light green at that exact moment. This whole black box problem creates another huge blind spot. See, an AI learns from the data we feed it, and typically that's thousands and thousands of hours of, normal, everyday, boring traffic. But think about it. When is a city ever truly normal? So what happens when something completely unexpected goes down? A major accident shuts down the freeway. A festival closes off all of downtown. A water main breaks and floods a major artery. If the AI has never seen that exact kind of chaos in its training data, it could just freeze up, or worse, make a terrible decision that causes total gridlock. At that point, you need a human to jump in and take back control. So we've talked about the tech, we've talked about the AI's logic. Now it's time for the ultimate reality check. How do you take this amazing concept from a single computer and actually apply it to an entire, sprawling, real-life city? So look, getting this system to work for one single, isolated intersection That's a tough engineering problem for sure, but it's manageable. It's been proven in labs. But a city isn't one intersection. It's thousands, tens of thousands, all connected. And when you try to scale this technology up, the complexity doesn't just add up, it explodes. It becomes a completely different kind of challenge, an epic one. And here's why it gets so mind-bogglingly complicated. Instead of one AI making one decision, you suddenly have thousands of AIs at thousands of intersections, all trying to coordinate with each other in real time. Each one has to track a crazy number of variables and constantly talk to its neighbors. Getting them all to work together as a team without creating a kind of digital gridlock is a huge research problem all by itself. And finally, even if we solved every single technical problem we've talked about today, we are still left with the last and maybe the highest set of hurdles of them all, the human ones. Because at the end of the day, the tech is only part of the story. The real-world barriers can be even bigger. We are talking about the insane cost of upgrading all that infrastructure, the bureaucratic red tape you find in any city agency, and the technical nightmare of trying to plug a brand new system into software that's decades old. Now, I know after hearing all of that, it might sound like this whole idea is a dead end, but it's really not. The source material frames this perfectly. These 7 challenges, they aren't failures of the concept. They're a roadmap. They are the exact research opportunities that brilliant scientists and engineers are tackling right now to build the next generation of smart traffic systems. So in the end, you have to see these hurdles not as roadblocks that are stopping progress, but as the actual blueprint for building the future of our cities. Which leaves us with a really fascinating final thought. With so many people working on these exact problems, the question isn't if we'll solve them, it's who is going to get there first.